Hey everyone, welcome back to my channel. You're watching Learn Tech with Sandip Das, and in this session today we are going to learn about infrastructure as code with GoLang, and in this cover what is the basics of Terraform and infrastructure code, then how to write custom Terraform providers in Go, then how to manage the cloud resources using GoLang, specifically AWS resources. I will show as demo, and then how to develop a serverless application in Go. And all this will cover in very practical. I have already have the code example. For example, Terraform providers, how to develop that. For example, using AWS SDK, how to create, destroy, manage the AWS EC2 instances, how to create the bucket, for example, and also example for serverless, which is AWS Lambda, how you can develop a Lambda application. And not just that, how to locally test, how to locally deploy to the remote cloud environment and test the remote APIs also using your local. And the tool that you're going to use that is the SAM. Okay, I have already covered in documentation also using AWS Serverless Application Model command line interface, which is AWS SAM CLI, how to do that. Okay, now let me go one by one and stay with me till the end so that I can make you understand all this concept and practically as well. Okay, so stay with me. Okay, now let's understand what is infrastructure as code and what is Terraform and why we should use Terraform. Okay, now what exactly is infrastructure as code? In short, we call it IaC. Now, it is a practice of managing and provisioning infrastructure using machine-readable configuration files rather than manual process, and it enables automation, scalability, and consistency in modern DevOps workflow. Now, why Terraform? Now, Terraform is a go-to tool for IaC because it supports multiple cloud environments and providers, making it cloud agnostic. And its declarative syntax simplifies resource management by defining desired states, and its state management feature make it easy to track and update infrastructure changes very consistently. Okay, now we're talking about infrastructure code, we're talking about Terraform, but where is the GoLang fits in? Now, GoLang is highly relevant for Terraform and IaC because Terraform is written in Go, making it ideal language for developing custom provider, which we're going to develop right now, and extending Terraform capabilities. And its performance and simplicity makes Go a great fit for the cloud automation tool. Now, without further ado, we'll simply go and jump into the writing custom Terraform providers in Go. But before that, let me give you a basic theory. Okay, so what are the Terraform providers? Now, by the way, if you don't know about Terraform, you should first go. I have the past videos on Terraform. You should go and check those out. I'll give the links. After you have the basic understanding of Terraform, come back to this session. Okay, but if you already know about Terraform, you have already tried that, I'll continue watching. Okay, now what are the Terraform providers? Terraform provider acts as a plugin that enables Terraform to interact with the different platforms, which managing resources such as cloud services, databases, and APIs. They define the operation for provisioning and managing infrastructure across various providers. Now, how we are going to manage all these resources, or how we're going to extend the Terraform capabilities using Go? There come the Go SDK or Go and Terraform SDK simply. Okay, and I will show you that. Now, what are those? Terraform has given us some SDK for GoLang, and we'll be utilizing those to create our custom Terraform providers, which is to extend the Terraform capabilities as a provider. Okay, and I'm going to show you right now how exactly you're going to do that. Okay, so the custom Terraform provider code is actually at Terraform_provider, which is under day 12. By the way, sorry for the long wait, I've been busy. Okay, now that was a due. Now, yes, so in the day 12 of the repo, in Terraform provider folder, inside there is a main.go file. Okay, and this is the starting point. Okay, now let me explain you the architecture a bit, and then I will show you how to build the plugin, how to utilize it. I will show you precisely. Okay, now the main part you should look at is first is the Go mod file. Okay, which is the main plugin. So we are utilizing HashiCorp Terraform plugin SDK version 2. Previously it was different repo and different thing. Now the current way of creating the Terraform providers are using this Terraform plugin SDK v2. Remember that. Okay, and use the latest version of GoLang. Okay, that's up to you. Okay, yeah. So first you start, I have given in the readme instruction. Okay, first go by, it's already set up, right? If it's not set up, then you should have done the go init and all that. But since already have set it up, we already have the go mod file. I have given the module name and everything. You can just go ahead and utilize that. So just simply done go mod tidy. Okay, I'll just explain. I'll show you also. Okay, so go mod tidy, and let's go back. Go to the particular folder. Let me just increase the font a bit. I hope you guys can see it. Okay, yeah, now go inside this folder, Terraform provider. Okay, run go mod init, go mod tidy. What will do, it will download the required module and all that, because it's already there, so it didn't do anything. Now let me explain the code a bit. So in the main go, you'll see you are importing TF provider. Okay, first thing. Now what is this TF provider? Now in the TF provider, this is a folder. Okay, see, this is the module name I have given inside the go.mod file. You can see the particular module name, and if you want to import something, it's very easy using the module name and then the folder path, that is TF provider. I can import that. Okay, so you see Terraform provider example / TF provider, we're importing that. Okay, now in TF provider, you can see dot provider. Now what is there? Now if you go to the TF provider folder, there is a file called provider.go. Okay, and the package name is TF provider. In that you will see I have created a function provider, and that is actually what getting utilized in the main.go. Okay, see TF provider, that is actually this particular function. Okay, and what you're doing in this function, you are returning a pointer to the schema.provider structure. Okay, and in this what you're doing, you're mapping the resource. So you see a resource map, and then we are doing the resource mapping with what, with the name of this custom resource type, and I will explain in the Terraform also. Now the name of the resource type is example resource, and definition or structure, all the functionality of it, it's inside this resource example. Now from where it's getting this resource example function, it's inside just below in that particular file, that's provider.go. Under just below that you will see resource_example.go file. Okay, now what you're doing here, again make sure the provider package name is same so that it can be easily get utilized in this. Okay, see here also package name is TF_provider, and here also the package name is TF_provider, so it's in the same package. Okay, and we have imported the, again it's plugging related SDK schema. So we are importing the schema, and you are defining the schema of this particular Terraform provider, or you can say it's the structure of that particular Terraform provider, and you can extend this particular structure. You can extend the capabilities by adding newer function, by adding your business logic into this. The example that I'm going to show you is pure basic, but in the future example you will see the magic happening there. Okay, now what you're doing here, we're creating a function that is a resource example, which is referring to the schema resource, which is we are importing here. Okay, now schema.resource, what is the resource definition? So in the resource resource, we are providing the structure, that is we are creating CRUD. Okay, so create, read, update, delete. It's about the particular resource life cycle. Okay, so in create we'll write the logic what it will do when it's create the resource. In read we will write the logic what it will do or how it will get the data or value. Okay, in the update, how we are updating the resource. Okay, and delete, how you are deleting the resource. Okay, and for each CRUD we have separate functions. So resource example create, resource example read, resource example update, and resource example delete. And just below that we have the main schema, which is the input value it's getting. Okay, or you're passing that in the schema. Okay, and what should be the input type? That is type string, and required true. If you don't, if you make it false, then it will be optional parameter. But if you make a required true, that means it will not function properly without. For example, you have to pass the API keys, or maybe SDK keys, or maybe authentication mechanism. Whatever is a required parameter should be defined in this schema and supplied here. Okay, and below that we see we have of course created. We want the 4 functions, right? This resource example create, resource example read, resource example delete, and resource all these functions, right? Update and delete. and that you have defined here. Now these are like, for now it's very simple looking function that in future sessions or future demos will make it more elaborated, more useful. But for this demo or this video or this particular lesson, try to understand the structure. That is more important. If you don't know the basics, you can never understand the complex part. Okay, so in the resource create, it will execute when the resource again is going to create. Okay, what you're doing here, we are setting the example value, the value that you're getting in as an input, that we are setting here. So d.setID, that is d.getName. So whatever value we are getting, the example value, we are setting as ID. Okay, and then we are returning the resource example read dm. Okay, now data, that is d for the data structure. Okay, so you can see the d for the resource data, and M for the interface is extending that. Now in the resource example read, it's not doing anything, but you can add your own logic there. For resource example update, it's just resource example read is just returning the same thing. We are not doing anything. This is because it's very simple one. Okay, and in delete, we are setting the ID as nothing. Okay, you can see, and returning null. Okay, so it's basically we're deleting. Now in reality, you will have your own custom logic, but for now understand, we need this as a structure. Okay, and then we have the code ready. We have the resource example, we have the function, we have the exact structure that you want with the schema, that is inputs or output on all that, and then we have the actual function where you will put your business logic. In upcoming session I will show that. Okay, now we have the code, we have the Terraform provider code in the main.go. What we're doing here, we are simply getting the provider function. So plugin.serve, this is the way, and see, this is the plugin we're importing. So Terraform plugin SDK v2 plugin we are importing here, and then plugin.serve, plugin serve point is a provider function. And what is the provider function? Which is the tf provider. Here you are returning this function, right? So this is how we are mapping in the main script. Okay, or entry point script here. Now we have the definition of the provider here, we have the functionality in the resource example here, right? We have everything set, but how we are going to utilize that in our actual Terraform code? For that, there is a detailed step which I have already mentioned in the readme.md file. So how we'll do it? First, let's create a build. Okay, so go build dashboard, there is output in the binary name is Terraform provider example. So let's do that. And it will create the file that is Terraform provider example, and you can see that here we cannot read because it's binary, right? Now what is the next? Now based on your OS, for example, my OS is Mac OS but using the M1 M2. Your could be Mac OS but Intel, your could be Linux, or it could be the Linux say ARM64, or it could be Windows. Based on your OS and the CPU architecture, you run the command. For me, it's basically this. So Mac silicon chip, make directory like this one I have to run. Okay, let me just copy this. Okay, and let me run. So ultimately what it will do, it will create a folder that is Darwin ARM64, and it will move this particular binary into this, okay, this particular folder. Okay, that it will do, and so that Terraform will detect this as a resource or available plugin. Okay, now what? Now let's go to the main Terraform code, and I have given that also. So you can see example use, where you will see the Terraform code, that is main.tf. But what is important is this part. Okay, see required provider, for example, we're giving name as example, and source. This is important because if you see in the that readme.file, see terraform.d plugin, and this is the ID we have given here, right? Now Terraform will detect that if you don't mention this in the Terraform main, it will not detect. But if you mention that directly, what is the source, for example, example.com, example, and what's the version, it will detect that. Okay, and then just mention the provider example. And if you remember in our provider code in resource example file, we have mentioned we want the value and it is required, right? So that's the reason we have to supply in the main.tf file. Okay, now how can we create the resource, and how can we utilize this particular custom provider? Let's go to the particular folder that is example use, and do ls. So we have the main.tf. So there's two Terraform init. Okay, if the plugin doesn't exist, it will import that here. this Terraform folder providers, and then let's do Terraform plan. Okay, it will show you what are the resources going to get created. You can see it's saying it's going to create this resource, that is a custom resource. Now it's able to detect, right? So example resource name is my resource and the value is the example name. Now how to apply that? Simply like normally how you apply it, just do Terraform apply and it will ask for the confirmation. If you do yes, see it's created the resource. Okay, now suppose you want to destroy this particular, because if you go to the state, see Terraform state, it's created the resource, right? Resource name is example name and all that. Okay, we have already have the value. Now if you want to delete, it's very easy. So Terraform destroy. Okay, so just run it and you'll see it's asking for the confirmation and it's removed that particular reference. So this is how very easily you can create custom providers of Terraform using GoLang, which is the main objective of this particular session. And of course we have more things to cover, but this is the most important part, how you can very easily create custom Terraform providers. Now this is a very simple, but you have to start from the basic to do most advanced things in your life, right? So this is your starting point. Now let me show you. I mean, we are done with the creating Terraform providers. Now it is next is to how can you manage the different resources using Cloud SDK. Let me show you that. Okay, so let's talk about managing cloud resources with Go. Now how we interact with the cloud resources. I mean, you can go to the console of the particular cloud console and do that manually, but we don't do that here in our productions. We do with the Cloud SDKs. Okay, and just to give you a bit of view of that, Go can interface with the cloud provider using cloud APIs or SDKs. Okay, for example, we have the AWS SDK for Go, and similarly we have the Google Cloud Client Library for Go. Similarly, we have the Azure SDK for Go, and I have given the link in the the slides, which will have that later on. Now I have some sample program that I've written, and I'll show how that works using the AWS Cloud SDK for the Go. Okay, let me show you that. Now for the AWS examples, let me clear the screen a bit. Okay, if you see there is a AWS example folder in the day 12, which is first, let's go with the S3 example, which is a very easy one. And you see we have imported mainly this. I mean, what is the SDK? So this is the SDK, AWS SDK for Go V2. This is the main SDK. Okay, and we are importing AWS config and the services of S3 because we are going to work with the S3, right? In the main function, we are doing what? By the way, for the setting up part, I have already given the instruction. How should we just run the Go tidy, and to run the application, just run go run main.go inside the S3 example folder. Now let me continue explaining the code. Okay, first we are configuring the region. By the way, before running this particular application of in GoLang, make sure that you have configured the AWS variables, AWS credential, or at least in the basic level you have configured the AWS CLI. It will make things a much more easier. Okay, let's configure the AWS CLI. Make sure that you have configured the credential, that is the secret and the key ID. Okay, that is the must here. Now in this code, we are first configuring, assuming that you already have the environment, like you have already set up the profiles or basic environment for AWS credential. Okay, and after that, if you don't know what I'm talking about, you should see my AWS videos. Okay, now in this first in the code here with configuration, you are first setting up the context, and then you are setting up the region. This is more important. Okay, the region part, you are setting as a region for US East 1. Now you can of course use any region that you want. You can make it an environment variable, so you can pass on dynamically. It's up to you. Okay, if any error, I'm just showing any that error, we are showing the details. Okay, in the log, I'm using the log module, right? So you can print the logs. Now next thing, we are creating the client from what? The config that you have specified here, the config. You are using that to create a S3 client. This S3.new from config. So we are creating the S3 client here. Okay, then we are of course using a variable, this bucket name, and say Sandip demo, because I already tested the code with the Sandip sample demo bucket. So we just renaming that to bucket 2 so that it will create. Okay, then we are running a function. Now all this documentation you can find if you just go to this particular. I will give the documentation links. You can just go and see the documentation for the different functions. Okay, so using S3 client dot create bucket, we are creating the bucket. Okay, just supply the bucket name and that's it. AWS.string bucket name. Make sure that bucket name is proper. Otherwise, anyway, I mean, if you are not providing the proper S3 bucket name, it will give you the error and you'll understand anyway, right? So that's not a problem. If any error, it will just print the error. If it created successfully, it will show successfully created the bucket name. Okay, now let's create the bucket. Now how to create the bucket? Just run go run then this particular script, that is main.go, and see it will create the bucket. So it's saying successfully created the bucket Sandip Das demo bucket 2, right? Now let me show you how to create read, like list out the different instances and delete the EC2 instance. The EC2 instance related or EC2 resource related command is in the EC2 example folder. Let's go to that particular folder, cd dot and cd go to EC2 example. Now let me explain that also. Now to get started, first make sure just run go mod tidy inside the EC2 example folder and run main go. But before running, let me explain what you're doing here. So if you come to this particular code of the EC2 example, for again, just similarly, we are configuring the region. So in configuration variable, we are storing the config. That is config load default config, and config we are setting the region as US East 1. By the way, we are importing AWS. We are importing the config EC2 and EC2 types. Okay. Then we are creating a EC2 client. So create a EC2 service client, which is EC2.new from config and SBC. Then we are also dynamically getting the AMI ID, because in order to run the instance, if you have ever done that manually, you had to select one particular AMI image or machine image, right? Similarly, here also you have to supply the machine image. For that, we are using this particular function. So get latest Ubuntu AMI, and if you go down, there is a function which is get latest Ubuntu AMI. We're just describing the inputs and we are passing on different filter. For example, I want Ubuntu 20.04 and that is AMD server, and architecture is 8664, and of course root volume that should be EBS, and owner is the canonical AWS official account. Okay, now that you are doing here, we are getting the ID, and then if anything error, of course it will print the error. Otherwise it will go to the just print the particular AMI ID, and then we'll create EC2 instance, and you have to supply the client and the AMI ID. Just we got it here, and then it will create the instance. Now if it can't create any problem, it will give the error. Otherwise it will simply create the instance and it will print the instance ID. In the next step, we are listing all the EC2, that is EC2 instance that we have that in our particular region that you have mentioned here. Okay, and after that we are deleting the instance that you have created. We got the instance, we stored the instance ID, right? So that instance ID we are deleting because I don't want to get billed for anything, right? So we are deleting that, and this is how we basically do that. Okay, and the moment after this I will explain the Lambda function, right? So you can automate creating of these resources, can automate all that via the Lambda also. But for now, let's focus there. We are deleting the EC2 instance by running delete EC2 instance function, and we are supplying the SVC and instance ID. If you go below, you see we have several functions. For example, we have used the this create. Let me go up. Yeah, create EC2 instance, then delete EC2 instance, list EC2 instance, right? We are passing the client. All that function you have defined below. So create EC2 instance, we are supplying, of course, as a parameter, we are supplying the client reference and the AMI ID, and we are using EC2 dot, like there is a client name, EC2 dot run instance output. Then we are giving the image ID, then we are giving the instance type, and then we are running the how many instances you want. I'm just running with one. Okay, then we are running the instance using svc.run instances as per the input that you have supplied here, and then if any error, it will print the error. Otherwise it will just simply print the instance ID that you are supplying it running here. Okay, similarly list instances, it will run the ec2 dot describe instances, describe instance input as an input, and then it will run svc dot describe instance context out to input, just to list out all the instances, and we'll just return if it had the instance, it will just print out. Okay, in the delete instances, we are just utilizing the function svc that we are supplying as a client dot terminate instances function, and of course we are giving the input that is as an instance ID we are getting or supplying in the function parameter. Okay, and that you are deleting here. If any error, of course it will error out. Now let me quickly run this go function, and go file, then it will become more clear. So run go run then the main.go file. Okay, See, it will first do what? It will first get the image AMI ID, then it will is creating the instance and is giving the instance ID, that is I, then the random thing. Then it's listing the particular instance because it's just recently created, so the state is pending. And again, since I mean it's a demo session and I don't want to get bill, that's why I'm just terminating the instance as well. If you see the down the code, yeah, delete instance function we are running, which we are defining this code anyway, right? That's how we are deleting instance. So using GoLang, we can easily create list, destroy the resources like this easily, right? So that's why these two examples are good enough to get started. And of course, there are many such things you can do in the cloud with the cloud resources using the AWS SDK. And the main SDK is this one, AWS SDK Go V2. Okay. Now this is about the AWS Cloud SDK example. You can do the similar things with the Azure and GCP as well. Now let's go to the next section. Okay, so that now we have learned about how you can manage resources, basically creating, deleting, managing the cloud resources using GoLang SDKs. Let's learn about the serverless application development and of course serverless architecture using GoLang. So how we'll do that? Okay, first, before jumping to the code part, let's first understand what exactly is the serverless computing. Now, serverless computing allows developers to run code without managing the infrastructure. And what does this mean? This means you as a developer can run code without thinking about what is the instance type, how you're managing, what is the VPC, and all this complicated stuff. You just deploy your code and it will run. Okay, now how that works? Okay, it's that cloud will automatically handle the scaling, managing, patching, and everything. You just run your business logic as the code. Okay, now how does Go work in this? So Go fit into this serverless platform like AWS Lambda or Google Function by offering fast execution and very low memory usage, making it ideal for efficient serverless applications. Now, I can cover all the SDK, but since this due to the time constraint, I'm just going to focus on AWS Lambda only. So come to the serverless example folder and look at this particular main.go file. And what you're doing here, you're utilizing what? AWS Lambda Go. Okay, we are using this library. Okay, so AWS Lambda Go and Lambda. This you're utilizing. First, you are defining the data structure, which is the name and the message is a JSON data structure. Then we are defining the handler, and this is very basic example. I'm not complicating anything because this is your introduction to serverless application development using GoLang. So we are keeping it very basic. Okay. Now we have the handler function, which is using the context, which is CDX. You can see the reference context, and you can see we have imported the context. Now we are using the request and using the of course request the parameter. We are sending the response. Okay. Now response coming from the context part. Now we are giving error. In case we are having error, we just give the error. Okay. Now return because it's a simple function. We're just returning whatever the input you're getting in the request. We are expecting that request have a field called request name or body field called name, and we're returning that. So we are calling message hello, then the whatever input we're getting as a name. And then in the main, we are simply starting the function using lambda.start, then the handler. Handler we are defined in this handler function. Okay, so it's very basic. Again, just to give you a kind of a overview, this is where you are defining the request structure. Okay, and if you see here, message is a JSON thing, and name, you can see the request here. The request you are expecting the name as the name data request data structure. We are expecting name here. Okay, and you are returning in the message that hello, then the name. Okay, that you are doing in the handler, and in the main block we are just starting the lambda function. Okay, now let's go to this. Look at this readme.md file. What you're doing here. Of course, if you are just running from scratch, you follow this instruction part, but you already utilizing this code. Just run go mod tidy. First, go to the folder first. This is inside the serverless example folder. So cd serverless example folder, run go mod tidy. If you don't have the mod packages installed, it will install automatically, and then run main.go. But if you run run main.go to test, it will give you error. And look at this error. It's saying some date expected AWS Lambda environment variable, which is the Lambda server port, Lambda runtime, and all that, right? So that didn't work. That is why we have SAM. What is SAM? Let me explain. So to test locally, should be installing AWS Serverless Application Model Command Line Interface, which is the AWS SAM, which is Serverless Application Model in short, long form. In short, we call it SAM. Okay, and how that I've already given you the link. So just go to this link and download it. Okay? Very easy. After you're done, template.yml. Okay, and let me explain the template.yml content. In that, you are giving the definition of the resource, which is the function name, which is Go Lambda function, and type is of course is the serverless function. Then properties, handler main. So that means the main file name is main.go, and then what is the runtime? The runtime actually previously, like few years back, we used to go 1x, but recently it's moved to provider.al2 or al 2023. Okay, basically use the best practice is to provide it like as a runtime, use provider.al12. 12 or 2? L2, not 12, sorry. Okay, and architecture is 8664. Even when you are building the application or function or binary, you should be generating the build for this CPU architecture, which is 8664. Okay, code URI is the current folder. What is the folder path? You have to provide memory and the timeout based on your application. You should be giving. I'm just giving the bare minimum because it's nothing. We're doing nothing specifically. Very small thing we're doing. Just printing the name, right? Then environment variable. Whatever the environment variable you need for your application, you should supply here. Okay. Now let's go back to the readme.md file. Like how to build or test locally. First, to test this particular main.go, okay, we have to build using the SAM. So how to do that? Just run this command sam.build. Let me clear the screen or terminal and run SAM build. If you do that, it's saying build succeeded. And by the way, let me show you how it's generating this. We have a make file. Okay, this particular called make file. Here you are giving instruction how to build. And if you come here, you see GOS Linux, which is the OS, Go OS, Go architecture, AMD 64, and then we are generating the binary as a bootstrap file. Okay, and then we are copying this bootstrap binary to the artifact directory. And what is the artifact directory? Of course, SAM will automatically create a AWS SAM folder. Inside that, there will be a build folder. Inside that, there will be a Lambda Go Lambda function. Inside that will be the bootstrap function. Okay, this is where SAM holds this particular artifact. Okay, so now you know that. So if you come here, build artifact done, build a template. That is what is the template URL getting used. And after you have the particular build ready, you can now test it. So how to test it? That also instruction I've given here. So if you come here, okay, make sure that before actually going to invoke and test, you must have logged into the AWS public ECR. Okay, and by the way, make sure that you are running the Docker also. That is also you have to make sure, like either Docker desktop UI or maybe inside your system you're running the Docker daemon part. Okay, so run this command. It will do the login part. See, ACR public AWS ECR public, get login pass and just logging into the public ECR. And after it succeed, let me just wait for that. You will run this command Docker. Like if it's Linux, you can just run this one. It will work. If you are not, you are running Mac like me. For me, it was required to utilize mention the Docker host URL and the so that is socket part, and then run this particular part. Okay, like special part is just mentioning the Docker host as a particular path. Okay, that is the only requirement I had. Just run it. By the way, you can see in the event you are supplying event.json file, and in the code itself I've given this event.json file. Let me just show you. Yeah, you can see that event.json. Here I'm just giving again just name part as Sandip, because if you remember in our Go code, we are expecting what? The request structure we are mentioning, we need the name, right? So that's why in the readme.md file, in the event.json, we are just supplying name. Okay, now let me run it and see. In the Go main file, we have said what? In the message, I'm just whatever name I'm getting, I'm printing it, right? So here in the message saying hello, see message hello Sandip. You can see that here. Okay. Now we have developed the application, we have locally tested. How can you deploy? So there are many ways to deploy, by the way, but if you are going to test using SAM, the serverless application model, so you can deploy using SAM as well. How? We'll learn about that. So if you come to the README file and see, this is the particular command, SAM deploy guided. If you, by the way, before running that, you have to make sure, before even running the SAM build, you have to make sure that you have properly configured your AWS, CLI in the local. That will be helpful. Okay. So SAM deploy guided, just run that. And it will give you a guided way. So what should be the stack name? I'm going to the default. What is the AWS region? Again, I'm going to the default. Like you can just go with the default. If you don't know what is saying, just go with the default. Okay, for now. Later on, we can experiment and see, saying that looking for resource need for deployment. It's creating the bucket name. Then it's generating the build. Then it's going to like deploy the application using the CloudFormation stack. See, it's saying uploading the SAM file and all that. Just wait for a minute and it will deploy the application. But after deploying, how can you test it? I'll show that as well. Okay, so don't worry. See, it's saying that so because I think it might not also do, because it's same code. I've not made any changes, so it will stay the same. So let's look for that. Update in progress. Just give it few seconds and it will simply run. Now, how can you test the remote environment? That is also very easy. So if you come, see, saying that successfully created update the stack. Okay, and the name of the stack is SAM app. You can give any name that you want. Okay, it's up to you. Now, if you come to the README, how we can test the remote API. So for that also you can use SAM. So SAM remote invoke, then the function name that you want to test, then the stack name that you have utilized, then the event JSON part that you have you're utilizing for normal local testing. Okay, so copy that, and if you run here, see, SAM remote invoke, then the function, that Lambda function name, the stack name, and you can easily test that. See, saying hello, like message, hello Sandip. So it give us a response, right? So this is how you can build, test locally, deploy to the production, your remote environment in AWS, and test remote. Like you, after deploying to the AWS environment, you can test for the AWS part also. Okay, but this is all automatically via SAM. You can do that via the look manually also. So for that, you first generate the build manually, then you can zip it, then you can create the role. Like for you, SAM will create this role automatically for you. If you don't use the SAM, you can do manually. Then you have to add as the policy. They have to specify the role you are in. Then you can run AWS Lambda create function to create that function in the AWS environment, and then you can test locally using AWS Lambda invoke. So you can do all that very easily via SAM, or you can do that manually. If you see your choice, you want to experiment that. So this is all about using Go. You can do infrastructure as a code. I hope that you like the session, and if you did, please like this video, share this video with others. All these code examples that I've shown, it's available in this particular repo. And if you go to this repo, okay, if you go to this repo in the day 12, you will get it. Okay, for now there is no code. Let me quickly push the code, so you'll have it. So just let me clear the screen. Okay, so clear the screen, and let's add this. Git commit. Say day 12 codes, and git push origin main. Okay, now you have the code also. Okay, and see, you have the code. So this is all about today's session. Hopefully quickly I will make the next session also. So yes, if you're new to this channel or this series, please do like this video and share this video with others, so everybody else also will learn about how to create custom providers using Go for the Terraform, how to use serverless application, how to use SDK, Cloud SDK using GoLang. Okay, so see you soon in my next video. Bye bye.